Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos. Hello students, good morning everyone. So today we are going to see how a 4-bar chain works, and we are going to find the velocity and acceleration of different links of 4-bar chain. So here's the question, first question. In a 4-bar chain ABCD, AD is fixed and it is 150 mm long. The crank AB is 40 mm long and rotates at 120 rpm clockwise, while the link CD is 80 mm long and oscillates about point D. BC and AD are of equal length. Find the angular velocity of link CD when the angle BAD is 60 degree. So this is the question. We have to find the angular velocity of link CD. So first of all, you have to draw the configuration diagram, that is the 4-bar chain you have to draw taking a particular scale. After you draw the configuration diagram, then you have to go to the velocity diagram, and after drawing the velocity diagram you can easily calculate the angular velocity of the link CD. If there is a question related to acceleration, that is angular acceleration, then you have to also draw the acceleration diagram. So if the question is talking about only angular velocities of different links, you have to draw only the velocity diagram. If it is talking about angular acceleration of different links, you have to draw the acceleration diagram as well. So here in this question there is only angular velocity of the link CD. So we can get the angular velocity of link CD just by drawing the configuration diagram and the velocity diagram. So let's start with the question. Let's start drawing the diagrams. Before you start drawing the configuration diagram, you have to check what are the lengths given. So according to the length of different links, you have to decide a scale. So if you check in the question, the lengths of different links are 150 mm, 40 mm, then 80 mm. So looking at the values, you can select a particular scale. So it depends on how much last diagram that you want. If you want a smaller size diagram, you can select a bigger scale. If you want a diagram which is very big, so you can select a scale which is very small. So here in this case we can take the scale as values are 80, 40, 150. So you can take scale as 20 mm is equal to 1 centimeter. Scale is 20 mm equal to 1 centimeter, and you have to start drawing the configuration diagram. The link AD is fixed link, which is generally at the bottom. The fixed link is always at the bottom, and the link AD is 150 mm long. So 150 divided by 40, 150 divided by 20 gives you 7.5. So I've drawn the link AD. Next is the angle BAD, which is given as 60. So next you can plot the angle. Now in the question, if you see, the crank is given as 40 mm. So I've selected a scale as 20 mm is 1 centimeter. So the crank will be, which is 40 mm long, which comes out to 2 centimeter. Now we've got the point B. Now we've got the point B, BAD. Next is the connecting rod. We have drawn the fixed link, we have drawn the link crank, that is AB. Now is the third, it's a 4-bar chain, so there will be 4 links. We have already done with 2 links. Now is the link BC. If you read the question, BC and AD are of equal length. So AD is 7.5, so BC is also 7.5. Now in the question it is given that CD is 80 mm, so 80 mm comes out to 4 centimeter. So we've drawn the configuration diagram taking scale as 20 mm equal to 1 centimeter. A, B, C, D is the 4-bar chain and the link AD is fixed. Now we can move on to calculation of the velocity diagram. Before you draw the velocity diagram, you have to see the direction in which crank is rotating. If you see the question, the crank is rotating clockwise and that too with 120 rpm. So you have to show the direction. So it is rotating clockwise with 120 rpm. So if the rpm is given to you, you can calculate the value of angular velocity omega of the crank, that is 2 pi n by 60. And you can also calculate the velocity of point B with respect to point A. Also the point B, the velocity of point B with respect to A will be perpendicular to the link, that is perpendicular to the crank, that is the length AB. So it will be perpendicular to the crank, and it will be in the direction in which the crank is rotating. So I've drawn the velocity of B with respect to A. It will be having this direction. Now we can find the magnitude of the velocity of B with respect to A. So V is equal to R times omega. So velocity of B with respect to A will be AB into omega of AB. But the value of omega AB is not given to you. Omega AB can be calculated using the formula 2 pi n by 60. So the value of omega comes out to 12.56 radians per second. We have to calculate the velocity of B with respect to A, which is nothing but R times omega. But the value of omega is not given to you, so you can calculate omega using 2 pi n by 60. So the value of omega comes out to 12.56. Now you can substitute the value of omega in the equation and get the value of velocity. So the value of velocity of v with respect to a comes out to 0.50 meters per second. Now we've got the magnitude of velocity. We also know the direction of velocity. Now you can draw the vector. The vector v with velocity of v with respect to a can be drawn because we know the value as well as the direction. So when you draw the velocity diagram, you have to select a scale. Before selecting a scale, you have to take a point anywhere in the page, and you have to name the point as a comma d, because the link AD is fixed. Since link AD is fixed, both the points A and D will be stationary, they are not moving. The other 2 points, that is B and C, as you can see in the diagrams, they will be moving, and A and D will be fixed points. So you have to take a point in the velocity diagram and name them as A comma D. Now you can go on to calculation of the velocity of v with respect to a. We have already calculated the velocity of v with respect to a, and the value of that comes out to 12.56. That is omega, I'm sorry. Velocity of v with respect to a comes out to 0.50. We also know the direction of velocity of v with respect to a. Now you can plot the vector selecting a suitable scale. So select a scale for velocity diagram. So since the value of velocity is 0.5, so let's take the scale as 0.1 meters per second is 1 centimeter. So the value of velocity of b with respect to a will be 5 centimeters since it is 0.5. So we've drawn the vector velocity of b with respect to a. Now we are done with the point B. Now let's move on to the point C. Since point C is connected to two different points, as you can see, C is connected to B as well as D. So there will be two velocities of C with of C. So velocity of C with respect to B and velocity of C with respect to D. So velocity of C with respect to B will be a vector perpendicular to CB, and velocity of C with respect to D will be a vector perpendicular to CD. So first let's draw both the perpendicular lines. So I've drawn the two vectors, that is velocity of C with respect to B, which is perpendicular to BC, velocity of C with respect to D, which is perpendicular to CD. Now we only know the directions, we don't know the magnitude, because if you want to calculate the magnitude of velocity of c with respect to b, we should know the angular velocity of the length cd, which is not known. If you want to calculate the magnitude of velocity of c with respect to d, you should know the angular velocity of the length cd, which is again not known. So what we can do is we can just plot their we can just drag the lines in the velocity diagram, and we can get the magnitude as well. So the velocity diagram is done. As you can see here, we've got the triangle. So earlier the magnitude was not known, the magnitude of velocity c with respect to d and the magnitude of velocity c with respect to b was not known. Now as the velocity diagram is complete, you can see their lengths are fixed, and now we can get the value of their velocities. That is, velocity of c with respect to d can be easily found, and velocity of c with respect to b can also be easily found. Now let's go on to the calculation part and calculate the angular velocity of length CD. If you want to calculate the value of CD, you should know this length CD, and you have to multiply it by scale. So first of all, let's measure this length. Now VCD is known to you. Now since velocity of C with respect to D is known, we can calculate the angular velocity of C with respect to D. Now CD has to be taken in meters, because velocity of C with respect to D is in meters per second. So the length CD should also be in meters per second. I mean, it should also be in meters. So the value of CD is given as 80 mm. So 80 divided by 1000 is 0.08. So the value of omega of CD comes out to 4.5 radians per second. So this is the configuration diagram, this is the velocity diagram. The velocity of C with respect to D is only known in direction. The velocity of C with respect to D is also only known in direction. The velocity of B with respect to A is known in direction as well as magnitude. So you can plot the line. Rest of the vectors, that is VCD and VCB, we already know the direction, so we can just drag these lines and we can get the triangle. Once you know the triangle, you can calculate the velocity of any of the part. Once you get the velocity, next is you should go on to calculate the angular velocity of whichever length is whichever length is asked about. So once you get the velocity, once you get the omega, the question is done. if it is only about angular velocity. If it is also about angular acceleration, you have to continue with the angular acceleration diagram as well. So I hope you've understood this. Thank you so much.